like actual calc
Mine's
material.
on one.
So, I'm mixing a couple of these sections, which is actually like derivative stuff and graphing, and that goes into chapter 2 stuff. Like, so I just put on that chapter. All right, because the first chapter didn't have a lot of this stuff. It was a lot of just pre-calc material. All right, so, okay, first, when we talked about graphs, we talked about the idea of like graphs being continuous and discontinuous, but I never really highlighted it or discussed it a lot. It was something that maybe done more in like algebra 2 and pre-calc. If you have a discontinuous function or a function that's continuous itself. So like for instance, a graph like this. This is something we did in pre-calc, right? That graph is considered to be discontinuous, right? There's an actual break in the graph, if that makes any sense. Now the weird part is every x is actually like used. So that it actually has all real numbers for a domain. It just, the problem is it's considered to be discontinuous because it's literally in pieces. It's a piecewise function. It's broken up. So that's the weird part, like when you look at it, right? It looks like it would be continuous by definition because every x is accounted for. Every x has a number that's in it. But the problem is, it's this new term that I want to talk about today called a limit that explains more of it. Okay, this is something I introduced the other day, and we never really got to a formal definition.
You said limits, like, you can be above it or below.
Yeah, a limit is like an approximation, right? So it's this idea that for every element in the domain, there exists exactly one element in the range such that, because now, here's the idea. I'm going to finish this sentence here in a second. That first part of the definition, for every element in the domain there exists one element in the range. That idea is that it's a function to begin with, right? A function has elements in the domain, like x numbers, and there is exactly one answer in the range, one exact y answer. It doesn't double over itself. Such that for every delta, and delta is this really weird symbol, that is less than, I think they say or greater than 0, I should say. Greater than 0, let's go over here. For every delta that is greater than 0, there exists an epsilon greater than 0, right? And you're looking at it going, what is a delta, what is an epsilon? It's big fancy Greek terms for x's and y's. That what we're talking about here is, let's call this some x value, okay? We know that's the x of 2, right? That's some x number. And what I want to be is, I want to be in a band around it that is within one delta, okay? Almost looks like a no, I don't know how they draw it. Things like that. Okay, it looks like almost a D with a tail or a D with a tail. Okay, you want to be within a boundary, right? So that's the idea, like when I talked about like a speed limit. You're approximately at a speed limit. You could be a little bit above, you can be a little bit below, but if you're within the threshold that they allow, you know, the officer will probably let it slide, right? Well, the idea is that when you're within this boundary, like one delta length, you want to squeeze the delta as small as possible, such that the element in, because this is like the actual answer. Do you agree? Like this is the answer, right where, you know, x is 2. You want to be within a certain, so if I go up here, you want to be within a certain, you know, certain epsilon number. This is the epsilon distance above it. Epsilon is this fictitious number above or below the graph. So you can go right and left on the x-axis, you can go up and down on the y-axis, but if you're within that same number, that's a limit, right? You want to be within that range. And the range is as small as possible. Okay, now that's the idea of like when we talked about speed limit. Like, yeah, you can be above or below, but you want to be as close to it as possible, right? Because obviously with the cars have the luxury of some cars, I shouldn't say all, but some cars have the luxury of having an actual cruise control. You want to be within a few degrees of it, right? A few miles per hour. And they'll let it slide, right? Some people try to push the limit on it. They try to go a little bit too high above it, and you get in trouble.
Are you giving me permission to speed?
No,
Push it
I'm
by
not.
A little bit?
Little bit.
Speed and
No.
swear and.
No, yeah. We're breaking all sorts of rules here. All right, so,
I've noticed
but
that.
here's the idea. I'll give you a better definition of this. I'll give you an actual, like, proper definition of what the book says. But what I want to talk about is, if you're within a certain boundary, above or below, that's a limit. Like, you just want to be close. So the idea of a limit can be applied to anything. It could be a speed limit. It could be the idea of like in a polygon, like in geometry class, when I give you polygons. A limit can be applied to a polygon, which is really weird. So like, here's the best definition I've ever heard from my math professor. Imagine you had a polygon. Now what is the name of this polygon?
Steve, hexagon.
Pentagon.
Pentagon, thank you. It's a pentagon, it's got 5 walls. Okay, not Steve or anything like that.
Just
Okay. The correct term for it, okay? Now, we've classified it as a pentagon. Now, here's the idea of a limit. What would the shape appear to be if you added more walls to it? So let's say instead of a 5-sided figure, I went up to, this is 5-sided. What if I went up to a 90-sided figure?
That's a big thing.
That's a Nigon.
It is a 90-gon, right? That's literally what we call it. We call it a 90-gon. Now, there could be other terms they would use, a Latin term for it. But what would it appear as?
A circle.
You just did a limit.
shape.
You're welcome.
Okay, so
You know that fire
the
truck
idea is
sound?
that,
enough, it's not a circle.
okay,
There's Barbara.
the limit is that, okay, the
You
limit
can zoom
as
in.
you approach, more walls, the idea is that it would appear to be a circle. Now, it won't be a perfect circle, but the idea is that it would appear to be because the walls would be so close together that you wouldn't be able to differentiate 90 of them, okay? At some point, there's that breaking limit where you can't really tell anymore. Now, on a polygon, there's definitions where the walls can't be like straight edges, where, like no segment connected to a common vertex can be collinear with each other. That's
What
the
theorem is
definition.
that?
What was that?
What theorem is that?
It's not a theorem, it's a definition of a polygon. So,
They call it a 90-gon?
it's called a 90-gon, that's the correct term for it. So,
That's the correct term?
yeah, so it's called a 90-gon. They just call it by the number of
When
walls.
did they
Is there a
stop?
scientific
When
term
did they
for this?
stop giving names?
They technically have names up through all of them if you just use a Latin term, like up through dodecagon. Eventually, I think like a 20-sided figure is called an icosagon or something like that.
So
There's
that
like-
one has a name.
Yeah, there is a name in like terms of Latin, but the correct terms that we use in math class, you would actually call it a 90-gon. I could call this one a 5-gon instead of a pentagon. But the idea of a limit is like understanding what would happen eventually, right? You're seeing the idea of like, where is it roughly approaching, right? Is it approaching one single object? Yeah. The idea that you figured out like what it would look like, that's a limit. Now, here's the problem. This example I've given you right here, this problem, it's discontinuous. It's not flowing from left to right side. It actually stops at some point. The weird part is, certain numbers up here actually have a limit, even though it's discontinuous. Some numbers don't. Like if I ask for the number 2, x of 2, like if this is my f function, right? So this is my f function, and I said I want f of 2. You could go find it, right? 2 is right here, and this is the answer at 2. That would be the number 3, right? So here's the idea. When I say that I want the limit of something, you need to be in a certain boundary. So what I mean by that is, here's the best way I can describe it to you. This is the term that we wrote down the other day. As x approaches 2, I want my limit for my function. Okay, so what I mean by that is I approach it from the right side and the left side, the positive side and the negative side. what would the number appear to be going towards? So, this is the right side, this is the left side. It appears that my answer is going to 3 in both cases. That's the limit, right? So on your circle idea, you'd think about, okay, what does 80 look like? What does 100 look like? When you kind of look from both angles, it kind of looks like the same picture. They look roughly like a circle.
120 gone, like, that's a complete circle.
Yeah, I mean, at some point your eyes just can't differentiate it anymore. And the idea is that this problem actually has a limit, right? If I'm going to 2. Now, if I said I want to go from the left side and the right side of -2, the right side and the left side of -2, now we have a problem. Now this problem doesn't have a limit anymore. The limit doesn't exist when I start approaching -2 from this side and this side. Why doesn't it exist?
2 different answers.
2 different answers completely.
2 different answers.
Okay, so going back to the idea of like a speeding ticket. You're too far out of boundary, right? When I approach from the left side and the right side of your speed, it wasn't going towards the number that's on the speeding limit. You know, like if it says 55, your number's too far out of bounds.
Like when fire trucks don't stop.
So the idea is that this number up here is approaching what, 4, this number is approaching 0. The delta band, the epsilon band here, is too far out of bounds. I want the epsilon band to be as small as possible. It can be above 0, but I want it to be as small as possible. I'm out of bounds.
You got me confused, Mr. Ward.
So,
I don't understand what you mean. In terms of the speed limit thing.
speed limit. If you know the speed limit is 55, right? So here's 55. Just imagine that's 55 on my graph. You can be, maybe I'll put it like this. You can be above the speed limit or you can be below the speed limit, but as long as you're within a boundary, you're fine. The problem is when you're too far out of bounds. When the speed limit's here and you're going this fast, right? You're going way above the limit, like where your speeding is. It's not even close.
What would you consider to
It's
be
not even close, right and left side. It's not close. You're like too far out of what they call their epsilon limit. I think most officers have like a 5 mile per hour kind of a limit
So.
where they give you kind of a band. Because it can come down to like your vehicle. It can come down to your vehicle where your tires are overinflated. You're going over the speed limit, you don't even know it. It can be underinflated, so you're going too slow. So they kind of give you a boundary because obviously the instrumentation in your car won't be exact. The radar gun that they're using isn't exact. It's approximate. So they do give you a little buffer. Most people think it's 3. It's about 3 to 5-ish in that range. But when you're outside that boundary, now you're looking at speeding tickets because you're outside the limit of where they're at. It's this idea of like the speeding limit's here and you're way too far above it. Your line doesn't even like appear to be getting closer to it.
So like the piecewise function, that's kind of like the one on top is you're in a 55, right?
Yeah,
And
you're
all
at
of a sudden,
55.
boom, it hits a 45 and you're still going 55?
Exactly. Because at that point, that's a great way to think of it. Because at that point, you had to be slowed down before you hit that street sign. Because you have to see it ahead of you, and you have to slow down. When you hit that sign, that's when you should be going that speed. When you're speeding up, like when you see the new speed limit sign, once you hit the sign, then you can slowly start to speed up to it. Like there's this weird limit where you're approaching that speed. Okay, question.
How far away does a cop have, or how close can they be to tell your?
I don't know. I always hear conflicting reports where it's like really close with the newer radars, but I've also heard of a report where they can like track you from like a mile away. I have no idea what that
mile?
It's annoying.
They can,
I honestly I want to
They're
know
coming
that.
at you, you don't know.
I
where
almost
it's at,
don't
you
want to
slam
know
the
that so I
brakes
can
next
push
to
my
you.
luck. But question.
You ever gotten pulled over
I have.
for speeding?
Yes.
How many times?
Once.
you're not,
Or you
$650 I did.
How fast were you going, bud?
70 on the interstate.
Wait, what?
Is it the interstate
That is the
70?
speed limit, though.
Yeah. I went into a construction zone and it was right there.
That's double fine, Sid.
Yeah. It was. He marked me 20 over. This is like the speed limit was 45. I was going 70. So he marked me like double over, and then he gave me the biggest ticket he could.
Yeah,
And I never had a
you
speeding
deserve
ticket up
that.
to
You
that
could've
point.
killed someone.
Were you like,
No, I wasn't. He's just like, well, have a good day. He wrote me a ticket and said go.
well, did it say?
Okay.
Did he say go fast?
Did it
So-
say too slow?
Did you start
He
crying?
just said,
That usually
why are you going so
happens.
fast? I just entered the construction zone. No one was even working. It was a Sunday. and he wasn't happy.
Was there a
He had
posted
bad
speed
day.
limit sign?
I caught him on a
Probably
time.
not.
I got a ticket using pre-calc.
You got a ticket using
I
pre-calc?
got out of it today. I got pulled over going, like, coming from the interstate onto the highway. So I was still going I was going like 68. I was like, how do you say that word? I was
You accelerate.
slowing down. Yeah, I was slowing down. I was doing like 68 to 65. And a state trooper pulled me over and I started freaking out and I was like telling him, I was just babbling and I said something about how I had just gotten new tires. And I learned in pre-calc that if your tires aren't the right size or they're inflated wrong, you can be going the wrong speed and you won't know it. So I told him I got new tires and I didn't know anything about my tires. So then he just let me off with a warning.
So you lied to a police.
Or,
No, I
We're
did
not
just
gonna
have
do
new
that, by
tires. Like,
or
Okay.
I would say.
my tires are 2 inches bigger.
Than what you had previously?
Yeah.
So you're going
back in
fast.
stock, but I looked it up.
You gotta go
Whenever I go through